A relation is a general connection between elements of two sets. Let's consider the following example. You start with the set friends, and the set friends is defined as the following list with Abby, with Eve, with John, and Hugo. And the second list, called ites, which is defined as the following real numbers: 160, 170, 180, and 190. Our goal is to make a connection between the elements of this set and the elements of this set. And to represent that connection, we are going to use what's called an ordered pair. Ordered pair. An ordered pair has two entries. The first for an element of friends and the second for an element of ites. Okay? So introduce here a friend and here an ite. And now you just make a list. You make a list of the pairs like this and you have a relation. So this is our first point of view to construct a relation. So the first point of view, you just choose. You just choose from this set and you start listing. For example, if you start with Abby, you have Abby, well, you can pair it with 170. Here it is, an ordered pair. Let's do it again. For Eve now. For Eve, let's pair it with 170 again. John, it could be 180. And finally, Hugo, let's pair it with 160. Okay? This is a list of ordered pairs, and so it is a relation. Let's consider another example, almost the same thing. You start with Abby again, Eve, 170 again, but now let's put Eve again with 180 and repeat the remaining of the set. 180 and finally Hugo with 160. Again, a list of ordered pairs, and so it is a relation. Okay? Now, it is useful when you have lists like this to give them names. For example, let's call the first list F. So F is an abbreviation for this list, and the same G is an abbreviation for this list. Okay? Now, this is the first point of view to construct from this set relations. Let's see the second. From the second, you have two steps. Step A, you make all possible combinations of elements of friends and ites in what's called the Cartesian product. Cartesian product. The Cartesian product between these sets is denoted as friend times ite. This symbol is an abbreviation. It is an abbreviation for the following set, which is essentially as all pairs of the form friend ite. Friend ite. Okay? You don't want to list all possible combinations. For example, this set would contain Abby 160, Abby 170, Abby 180, Abby 190. Then again, Eve 160, True 190, John again 160, 190, and same for Hugo. Okay? I don't want to list everything. So I just use this shorthand notation to explain what would I have to do to construct all possible combinations, all pairs of that form. Okay? So it is just to save time. Okay? Because it's not important that you list. What's important is the idea. The idea that you have a set that contains all possible combinations. Now you can imagine what that set would look like, and that suffices. Okay? So this is step A, to construct a relation out of this thing. Let's see step B. The step B is simple. You just choose. You just choose from this Cartesian product. You just choose the elements that you want and you put them in the set. Okay? Now, both the first and second point of view, ways to construct relations from these two sets are equivalent. However, the second one emphasizes a very important aspect, which is relations are subsets of Cartesian products. So in particular, F is a subset of friends times height, and so is G. Okay? Very important idea. Every single time you see a relation, you know there is some Cartesian product, and this F and the relation is some subset of it. Okay? Now let's now focus on F and G. F is a function, but G is not. Why is that? Just look at it. If you call for Abby, you know that her height is 170. For Eve, 170. And John, you know unquestionably it's 180, the same for Hugo. But now let's focus on G. For G, you know that Abby was 170. Eve now has a problem because it has two pairs, so there is two heights assigned to Eve. And so there is an ambiguity while working with G. You don't know what you are assigning, what element you are assigning to the first entry. Okay? So as a result, when you're looking at F, the first entry only appears one time. So Abby only occurs one time. The same for Eve, John, and Hugo. For the second set, for G, this is no longer the case. Eve appears twice. Okay? So this is another way to distinguish whether you are talking about a function or just a generic relation. Okay? So functions have that property. That property that the first entry is assigned unquestionably to a second entry, or said in other words, the first entry only appears one time. Okay? Now, with all the ideas in mind, let's now summarize into a definition what we just discovered. The definition of function. So definition. Definition is like in the dictionary. You are going to define what it means, the word something is a function. Let's see. We have our assumptions. Let big X and big Y be two sets. It could be any set. Previously, X was friends and Y was height. Okay? So, but now it is general. Any set works. A function, let me write it this way. To say that F is a function, so this statement is equivalent to say a list. So F is a list. Let me write it like this. F is a list of xy's, where x belongs here and y belongs here, with the property. What's the property? Well, let me put it in blue. Each x only has one y. Okay? So this statement is an abbreviation for this statement, okay? Which is essentially describes what F must look like. Notice that this is the definition as seen from this point of view, okay? It is the list that you constructed that has this property. Each x only has one y. Let's see an equivalent version. So again, F is a function. What does it mean? It's equivalent to what? F is a subset of x times y. Okay? It's a subset, just like we saw before. But not just any subset. Well, because a subset of a Cartesian product is a relation, but we want more than that. You want it to be a function. And so it's not just any subset. It's a subset with the property, with this property, each x only has one y. But let me write it in a more sophisticated manner. For all x which occur in the pairs of F, there exists only one y in those pairs that make the following true. X, y belongs to F. Okay? For every x in those pairs, there exists only one y that make x and y belonging to f. Now, this might be at first be quite a complicated way of saying what we wrote here, okay? But soon we will see examples where we're going to see exactly what this is supposed to mean in those examples. And I hope in with those examples this is going to be clear, okay? But this is the idea. You want just a subset with a special property, okay? Now, with respect to functions, there is still two more definitions that I want to give you, which will be very important throughout this entire course, which is the definition of domain. And so, the domain of the function is defined as all x's. All the x's that appear in f. So, D sub f is the set of all x's. The range R of f is defined, let me just write it, defined as all y's that appear where? In f, okay? So R sub f. What's y? Y has a special name. Y is called the codomain. Y is usually our choice, okay? The range is not, depends on f, but y is usually our choice. X usually doesn't have any particular name, okay? But many times, as you are going to see, x will be the same as the domain. So let me write this. Write it. Df may or not be x. So I recall, x and y are the starting points. You need to specify what this thing is. After you specify what x and y is, then you construct the Cartesian product and then you choose a subset, okay? And once you choose the subset, you have in turn df and rf. It might happen that the f that you chose, the df is in such a way that it's exactly equal to the original x, okay? For example, in f that happens. Abby, Eve, John and Hugo were in x, but the domain of f is is Abby, Eve, John and Hugo. So in this particular case, you are already seeing that the domain of f is the same as x, okay? Similarly, for the range of f may or not be y, okay? These two sets come as a result of specifying d of f and will be very important to understand the behavior of f, and we'll give great focus to them throughout the examples and throughout the course, okay? So now, let's move into the examples.